Welcome. This question says an 8 kilogram particle with a velocity of plus 3 meters per second collides perfectly inelastically with a 2 kilogram particle that has a velocity of minus 4 meters per second. And what is the velocity of the combined particle after the collision? Perfectly inelastic collisions occur when the two masses combine, they enmesh each other after the collision. So if I visualize this, I have 8 kilograms, and this is traveling to the right at plus 3 meters per second, and then this collides with a 2 kilogram body that has a velocity of minus 4 meters per second. And then after the collision, we have a combined structure. And this has, because it's combined, it has one velocity for both particles. They stick together. It's a collision, and in all collisions, the momentum of the system before equals momentum of the system afterwards. So Pi equals Pf. And I can write it down as saying M1 V1 initial plus M2 V2 initial is equal to M1 plus M2, because they stick together, V final. You can just call that V final. So if I put numbers in, I can say 8 times plus 3 added to 2 times minus 4 is equal to 8 plus 2 times V final. And I like to write it down as 8 plus 2, so when I'm checking over my work, I reinforce the idea that I'm adding these two guys together. I like to put every step down on the paper because I carry less information in my head, and there's more information for when I check my problem. So if I do make a slip, I have a much better chance of finding it than if I did half of the problem in my head and I only jotted down a few things to remind myself. So this is plus 24 added to minus 8 is equal to 10 Vf. So rearranging, 10 Vf is equal to 24 minus 8, which equals 16. So Vf is going to equal plus 16 over 10, which equals plus 1.6. And here, 1.6 meters per second. And here, the positive sign means it is traveling to the right. So this is a perfectly inelastic collision, which means that the two particles stick together after the collision. And just a word of kind of caution. In this question, I say, what is the velocity of the combined particle? Which again reinforces the idea that it's an inelastic collision and these guys stick together. But I could just as easily tell you that it is a perfectly inelastic collision, but then ask you about what's the velocity of the 8 kilogram particle. And it's the same as the combined system, so it would again be plus 1.6 meters per second. But I'm not giving you that double hint, combined particle and perfectly inelastic. So I say perfectly inelastic, but I don't say combined particle. It's quite a legitimate question. Alternatively, I could simply say the two particles combine together after the collision and not use the phrase perfectly inelastic. So don't just learn, don't just look for a couple of words and then learn a methodology. You've got to visualize every time. And there we have it.